Well, thank you everyone for
Hey
joining.
there.
I'm going to go ahead and get started. So welcome to today's webinar, Comprehensive Battery Passport Solutions for Next-Gen Energy Storage Systems, brought to you by Tech Online, eInfochips, Aero Electronics, and broadcast by AspenCore. I'm Colleen Heckman. I hope you can hear me now, and I am your moderator. You will find that your resources are located along the top nav bar. You can also download a copy of the slides by clicking on that today's slide deck on the right side of your console. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the submit button. If you experience any technical problems during this webinar, just go ahead and type your issue into that same Q&A text area, hit the submit button, and we'll be glad to offer one-on-one assistance. And now, on to the presentation. Comprehensive Battery Passport Solution for Next-Gen Energy Storage Systems. Discussing today's topic is Amr Al-Wakil, Director of Engineering, eInfochips. Amr has 18 plus years experience in the multidiscipline engineering for different fields like automotive, medical, IoT, and industrial automation. Amr has experience in product development that includes embedded software, hardware, mechanics, software, cloud applications, production, and quality management systems. Joining ARM today is Shaylin Shah, Manager Solution Architect, Level 2 at eInfochips. Shaylin has 22 years experience in multidiscipline engineering for different fields like telecom, IoT, data analytics, AI/ML, and industrial automation. He has experience in products development that include cloud-native software, IoT-enabled cloud applications, and quality management systems. And finally, kicking things off today for us today is Ollie Lentz, Engineering Manager at Aero Electronics. Ollie is an experienced engineer with over 8 years in distribution industry, primarily focused on battery management systems. His technical expertise began with microcontrollers, shifted to automotive industry, and then toward battery management systems. It's with great pleasure I now hand things over to Ollie to begin. Ollie, take it away.
Hello. Hi. Thank you very much, Colleen. My name is Ulrich Lenz, and as she already told you, I'm actually from the beautiful city of Frankfurt in Germany, and I work as an engineering manager for global strategic marketing in the sectors of energy management and building control. And it's true, I'm coming from the automotive field, and then I became the expert for battery management system within Europe, and now I changed again for technical marketing. Today, the topic will be battery passport, and especially for the EMEA region, but we have a slight feeling that this battery passport will be rolled out not only here, but also in the Americas, and let's see for sure, or maybe not, also in Asia. And before we start, a few words about Aero Electronics and our daughter company, eInfochips. So Aero Electronics was founded in 1935 as a radio store in New York and became what we have today, a company with more than 20,000 employees worldwide in over 85 countries. And with 36 distribution centers, we are one of the largest distributors in the world. However, we have long been aware that simply moving goods from A to B is no longer sufficient and have therefore specialized in other areas within this field. Responsible in various sectors such as industry, automotive, and aerospace, but also leader in the areas of security, supply chain concepts, well, which makes sense because we come from this field, but also cloud computing and strong in engineering services. But Aero is not only an ingenious and competent service provider, we also demonstrate social commitment with a technical and futuristic background. We are committed to a greener planet, as demonstrated by the OICA project in Indonesia and safe water in India. But we also show that physically impaired people can live what we consider to be a normal everyday life with the help of high-tech prostheses or semi-automated cars. And to combine those or summarize Arrow Electronics in three pillars, we are on the one hand the component business, which the one we are coming from, like shipping goods from A to B. And then the second pillar is, we call it enterprise computing solutions, but it's data centers for large customers and cloud-based application, like we know it today as AWS, or of course a lot of AI calculations. And then we have the third pillar, engineering services. And with engineering services, I want to present you a company which has already 30 years in the market with 3,800 engineers, and each of whom has completed over 80 hours of training. There was a heavy investment in time to achieve expertise and certification, and working closely with our manufacturers to be able to use their technology for you. And this close cooperation enables us to have the latest and best technology and the knowledge to use it to solve actually your problems. And eInfochips, the company I'm talking about, actually works closely together with Qualcomm, NVIDIA, NXP, AWS, Microsoft, Teoglas, and these are only some of them we're very closely connected to. And I mean 30 years, that means a lot. So give me the chance to give you a short introduction into the history of eInfochips itself. eInfochips by itself was founded in 1995, so we have a round year, it's 30 years definitely, and it was founded in Ahmedabad in India. And initially the company was a provider of chip design only. And then in the 2000s, embedded systems and engineering services were added to the portfolio, but also edge computing, machine learning, and security became a huge topic in the eInfochips developments. And then Arrow the acquisition by Arrow took place in January 2018. And under Arrow Electronics, eInfochips continued to innovate and expand its services offerings. It focused on emerging technologies such as Internet of Things, artificial intelligence, cloud computing, and of course, the digital transformation. And yes, it's true, I'm reading all of this, all of my speech, but I saw those guys in action, and everything what's following now is just the truth. Throughout its history, eInfochips has maintained a strong commitment to customer satisfaction, quality engineering, and technology excellence. The company has become known for its expertise in embedded systems, in software development, and semiconductor design, and innovative solutions across various industries. And that's the thing I also did not know. Oh, it's really jumping here. Well, whatever. Go to the next then. Or let's stay here. I don't know. Yeah, what I did not know is that they were an inventor of a lot of world's first designs. And there's a long list of actually things they did for the first time in the world, like a touchscreen in airplanes, for example, or the first IP-based camera for home automation. And then there's another long list of awards in eInfochips actually got, and this is exactly as long list as the other. You can start scrolling and you cannot stop it. But enough about our companies. Today we are talking about Battery Passport, and as you can see in the slide I just opened, there are quite a few keywords to cover. My colleagues Shalin Shah and Amar El-Akil will get you an introduction to battery passports, explaining EU regulations, the technical architecture behind the cloud infrastructure, the digital twin, and of course, the new possibility of recycling. So please welcome with me Shalin Shah, to whom I will hand over now.
Thank you, Colin. Hello, everyone. Good morning. I'm Shalin Shah, and I work as a solution architect at eInfochips on the cloud technologies. Today, we are going to talk about Battery Passport solution, its global initiative, regional adoption, and the purpose. We'll also focus on the value across the battery ecosystem and the impact of passport. We'll also talk about the key use cases and data attributes associated with the battery passport specification, eInfochips relevant service offering, the technical architecture, BMS integration and the reference design on the cloud, and we will touch upon the case studies. The global initiative for a battery passport has emerged in response to increasing concerns around sustainability, traceability, and circularity in the battery supply chain, especially with rapid growth of electric vehicles and renewable energy. So, what is battery passport? It is essentially a digital record that contains detailed information about the battery, such as material and composition, like what is the make or the material being used within the battery, its manufacturing history, carbon footprinting, ethical sourcing of the raw material, and its ESG data, which is related to the battery health and its performance, and how the battery is being used as for an end-of-life handling. Such detailed information about the battery helps in maintaining the supply chain of the battery. So Global Battery Alliance, backed by the World Economic Forum, is spearheading the development of a battery passport framework. And it is being largely supported by industry involvement such as governments, automotive companies, likes of Tesla and Volkswagen, and the mining companies, technology service providers, in collaboration with Global Battery Alliance, has contributed to the development of the framework. Let's look at the global adoption across various countries and regions across world for battery passport. To start with, European Union has put a strong foot forward for digital battery passport that needs to be implemented for all the batteries more than 2 kilowatts by Feb 27. So that's a very strong implementation of the battery passport. Other countries such as US, United Kingdom, and India, they have started looking at battery passport as a potential digital information of the battery for environmental health, and government initiatives or policymakers are in process to pursue it. Other countries like Canada, China, and Japan, they are also trying to follow the same thing. If I talk specifically about United States, there is no federal mandates, same as European Union, in US for battery passport implementation. However, the Department of Energy and Environmental Protection Agency are supporting the battery supply chain transparency. States like California, they are exploring extended producer responsibility rules. That means, let's say, if the goal is to have policy where producers are given responsibility for the entire life cycle of this product, including the end-of-life management. This means they are accountable for collecting, recycling, or properly disposing their battery products after consumers have finished using them. And the goal is to encourage the sustainable product design and waste management practices. So essentially what it does is it shifts the burden of managing the battery product and its waste away from the government and consumers to the producers. And in response to it, the producers are given the benefits so that they can design the efficient batteries over a period of time. This is a part of the initiative where US government is looking to fight the inflation, primarily for clean energy and climate action. So let's look at the European Union specific battery passport implementation specification. The European Union has mandated that the battery passport is required from 18th February 27. So it comes in force from February 27. The scope of the battery passport includes light means of transport, vehicles, or industrial batteries with more than 2 kilowatts, or an electric vehicle batteries. In a nutshell, any battery that is being placed in the market with more than 2 kilowatts needs to comply to the specification. The responsibility for implementation of the battery passport lies with the economic operators who places the battery onto the market, such as automotive OEM manufacturers, car manufacturers, or renewable energy storage companies, ESS companies who are using the battery for supplying the energy to the home, or any company who deals in electric vehicles or the light means of transport. Access to the battery passport data is categorized based on the role of a user who is accessing the data. So the customer or the operator who implements the battery passport must provide the data based on the role of the user who is accessing the information. So information pertaining to general public or generally accessible details, data specific to notified bodies or authorities, or any legal person with the legitimate interest in accessing or processing the information should be given the data according to their role. So the solution of the battery passport has to be implemented to support the role-based data access so that any person within this group can access the right and relevant information. So let's look at the different kind of batteries and the application that requires the compliance to the battery passport. So the industrial and LMT batteries, which is marked in dark blue color here, needs to comply to the battery passport regulation. So LMT and EV batteries specifically needs to comply to the battery passport regulation. So any EV battery more than a 25 kg weight, or an LMT battery which is less than or equal to 25 kg has to comply to the battery passport. Specifically for industrial batteries, batteries with more than 2 kilowatt in nature has to comply to the battery passport regulation, irrespective of the kind of a use case that is being implemented in. So let's look at some of the use cases of the battery. So let's say a battery could be deployed in a stationary energy storage system delivering energy to the grid users, or it's just used for internal storage. So any kind of such batteries being used for an external storage, such as standby battery, such as UPS in hospital, or any kind of a battery that is being used to supply energy with more than 2 kilowatt has to comply to the battery passport regulation. The other industrial batteries which is used in off-road transportation, such as heavy machinery or forklifts or electric logistics, has to also comply to the battery passport regulation if they are more than 2 kilowatt. So in a nutshell, batteries having either more than 2 kilowatt in weight in an industrial segment has to comply to the battery passport requirement, or LMT or EV batteries must comply to this need as well. So we go more deep into battery passport, its purpose and the roadmap. So battery passport, in a very simple word, represents a digital twin of the physical battery. But what is the aim? The aim is to bring transparency to the global battery value chain by collecting and exchanging, collating and reporting trusted data that people can vouch on among all the life cycle stakeholders on material, provenance, and battery chemical makeup, manufacturing history, and its sustainable performance. So the expected outcome of the battery passport, the first goal is transparent operation. Provide the full transparency in making of the battery, its practices along the value chain. That includes the information about what is being used within the battery, chemical makeup, and the manufacturing history. Sustainable innovation. A battery that is being manufactured can be used for multiple purposes. It could be new, repurposed, and can be used in multiple use cases. Circular economy. Make sure that the battery that is being used, manufactured, is a product that saves resources for the environment, and the battery can be repurposed for a different type and kind of use cases depending on its value. The way battery passport regulation in European Union is laid out is with 2025, the goal is to track the carbon footprinting, keeping the aim in the mind, so that battery manufacturers must have their carbon footprinting health data being checked and verified, available online. Battery passport mandate, so all the batteries that we talked about must comply to the battery passport. And the third is sustainability assessment. So the battery has to undergo thorough sustainability assessment to comply with the carbon footprint limits. Assessment includes technical documentation, specifying the percentage of cobalt, lead, lithium, and nickel derived from the recycled material. The battery passport and its value across the battery ecosystem depends on who is accessing the data, such as authorities, who needs to make an informed policy decision, needs an accurate data on the battery stock and the different life cycle stages, so that they can design the policy based on the fact. OEMs, who needs a data for a supply chain transparency. What is the due diligence report, carbon footprinting, so that they enable the comparison of the supplier with the possible impact on the choice of the supplier who should provide the battery to them. Consumers needs comparable data about the performance and the carbon footprinting of the battery, so that they can make an informed purchase decision about the type and kind of a battery that they want to purchase. The second-hand user, they need a residual value, so that based on the durability of the battery, they can decide the second life application of it. For example, an automotive battery could be used or repurposed for an energy storage system. The next is a collector who needs a precise information about the type and kind of a battery and its impact, so that within the history they can decide what kind of a transport a battery should be provided with. If it is hazardous, they should choose the transport accordingly. Then the recycler. Recycler needs an information on the composition and dismantling of the battery, so that they can choose the right set of method for recycling of the battery and ensure that they optimize the dismantling process. So that's how the whole battery ecosystem and the value chain needs an information from the passport that requires a implementation. So let us understand the 7 direct use cases of a battery passport. These use cases are across the battery passport value chain that we discussed earlier. These are the direct 7 use cases that are implemented based on the mandatory data attributes defined in this specification. So we'll first understand each 7 of the use cases, and then we'll see how they are being mapped to the ecosystem. Reliable communication of the ESG data. So companies who are selling batteries with an outstanding ESG performance, example, due diligence report, carbon footprinting, they could leverage this use case for a battery passport and their battery product differentiator. It's differentiate their batteries based on the data performance. The second is an informed purchase decision. Access to the reliable and comparable information about the battery. Example, its carbon footprinting and durability. It facilitates the well-informed purchasing decision. Eased servicing. So any information on the design and characteristics of the battery, example, dismantling, spare part, that facilitates the servicing activity, especially for the independent workshop, is very essential and vital. Precise risk assessment for transport of the used battery. So any information about the history of the battery, its accident, number of deep discharge events, supports the correct categorization of the battery, which minimizes the risk of using insufficient transport precautions. The use case about more efficient recycling process talks about the availability of the data on the battery composition and dismantling that enables more efficient recycling processes by reducing sampling efforts and optimizing the dismantling process. The simplified residual value, which determines the performance and durability of the remaining capacity of the battery, that enables the different businesses and private users to better assess the value of the battery so that they can decide what is the second use application of the battery. Last, streamline trade of used waste batteries through the marketplace. That means a marketplace could optimize the matching of supply and demand by utilizing the comparable information from the battery passport, connecting the right buyer with the suitable batteries, reducing the transaction cost. Having the understanding of these 7 use cases, they are mapped into the ecosystem value. So an OEM, they need the reliable battery information. Similar way, the people who are buying, they need to understand the value of the battery, make the informed purchasing decision, its service capability. And the rest of the value chain needs information about the dismantling process, the transport required, and the residual value that is useful for second life application of the battery. So here are the data attributes, data categories that helps implement the relevant use cases in terms of compliance to the battery passport. The battery passport data is categorized into 7 different categories, such as general information, label and certification, carbon footprinting, supply chain due diligence, material and composition, circularity, and performance and health or durability. This data maps to the relevant use case. So if a carbon footprint data is required, this category of data needs to be implemented. With eInfochips reference solution and the architecture that we will be talking, eInfochips has implemented performance and durability category data with respect to the state of the health, state of the charge, capacity and energy related information that is being fetched from the battery management system and being showcased to the end user on web portal and the mobile application. However, the reference architecture and the cloud design will be capable to capture any of these 90 data attributes to implement the relevant use case and help you comply to the battery passport regulation. Introducing eInfochips battery passport solution. There are 5 major components that constitutes of the battery passport solution. First is the collection of the battery data. So the solution captures the battery information such as SOC, HOS parameters from the battery and transmit it back to the cloud through the real-time data exchange between the battery management system and the Azure or AWS cloud. The solution is implemented with hardware security and security at cloud. So the data is stored in an encrypted fashion and being transmitted securely back to the cloud. The cloud platform contains the robust and scalable infrastructure with backend application that stores battery data and has the ability to perform the data analytics and AI/ML on top of it. And the front-end app such as web and mobile app is developed for showing the battery data on the dashboard with the real-time information. We'll now look into the eInfochips battery passport service offering. It starts with the data acquisition from the battery pack or the BMS system, which acquires the parameters such as state of the health and state of the charge, capacity, energy, and critical events of the battery from the battery management system. Then there is a connectivity piece that enables the battery management system to securely transfer the data from the main battery controller to the software application layer running on the battery management system via RS-485, and then communicate the data over an MQTT back to the cloud. So the cloud can have access to the data, and the data collected from the battery management system will be available via the secure element over NFC as well. The third service offering is a cloud backend platform development where backend application related to battery passport will be developed on the cloud, which has configuration, infrastructure setup, and security implementation for data at the rest and data at the transit. There is an application development service offering that includes wireframing UI UX work to showcase the battery passport related data onto the Android and iOS mobile application, and the real-time dashboard shows the health of the battery. The security implementation and the service offering enables the compliance to the cybersecurity specifications such as ISO 21434 and IEC 62443. That includes the embedded security implementation such as SSL and TLS implementation. The cloud and battery management piece that includes a digital twin and AI/ML capability where we can work on the advanced use cases of deriving the battery life from the overall data that is being collected. So these are the service offering of eInfochips. I would now like to hand over the control to Amra, who will explain the architecture and technical integration with the battery management system for the battery passport. Over to you, Amra.
Thank you, Shaleen. Hello, everyone. From this point, we will move from the cloud perspective into the system hardware and firmware perspective of the battery passport. Here you can see a generic architecture for a battery passport solution. At the center of this setup, we have the BMS microcontroller. This microcontroller acts as the brain of the system. On one side, it connects via iSPI to the battery module. And these modules, of course, include the battery cells along with a secure element that guarantees authenticity and data protection. The BMS itself also has a secure element. For local access, this microcontroller is linked to a PC GUI application over USB or Ethernet, and it can also talk to a mobile application via NFC. Additionally, the gateway connection over Ethernet is used to send secure data directly to the cloud database. The mobile application can also collect information from both the BMS MCU and the battery module, and then forward these securely over 5G or LTE into the cloud. So, overall, this architecture enables flexible and redundant ways to collect and send the critical battery passport data, making sure it is always available whether the system is online, offline, or even during service. This is a generic solution. Now, let's see how it looks with a concrete example from NXP. As an example of the generic concept, let's explore the NXP battery passport solution. Here, the system is built around a BMU board, which is connected to both a BGP and multiple CMU boards over TPL cables. The CMUs are linked to a battery emulator, which in this case acts like a real battery pack via CT cables. The BMU provides multiple access points for data. It connects to a PC GUI application over USB. It links via Ethernet to gateway, that communicates with Amazon Web Services Cloud, and it also supports NFC connectivity to a mobile application. Now, what kind of data can the user get? We are talking about the key battery health and performance indicators like state of charge, state of health, cell voltage, and temperature data. This data is stored securely on the BMU and can be uploaded to the cloud in two different ways, either through the gateway or through the mobile application. This ensures flexibility and reliability in data reporting. In the next slide, we will focus on how this security is actually implemented inside the system. But before that, let me hand it back to Shaleen for the next section.
Thank you, Imro. So we now look at the AWS Cloud Reference Architecture of eInfochips for Battery Passport solution, where anything on the client device represents the battery management system that communicates over an MQTT broker back to the gateway device. So the gateway device is responsible to store and transmit the telemetry data onto the AWS cloud. Gateway device includes the AWS Greengrass client that accepts the telemetry from the battery management system and process the telemetry data back to the cloud. This gateway device is trusted based on the X509 IoT certificate-based authentication and has the ability to publish the messages over MQTT topic back to the cloud. The AWS IoT Greengrass cloud service running on the AWS accepts and transmits the data back to the right topic and store it in the DynamoDB. So all the battery related telemetry data is stored, including the health parameters, SOC, SOH here. There is also a signature verification process. So any data that is coming from the battery is verified before it is being pushed back to the database to ensure that data is coming from the right source. The data stored in the DynamoDB is then available to mobile client and web portal to be displayed on the end user and end client. The entire architecture is designed on the serverless framework so that it can scale to n number of batteries and is secure in nature so that it accepts the trusted data only from the gateway device that communicates back to the multiple batteries onto the field. eInfochips reference architecture on the Microsoft Azure-based platform for battery passport solution. It has the batteries as a device and they communicate via the gateway to the cloud. So the device provisioning service helps authenticate the gateway, and the IoT hub service accepts the telemetry data from the gateway back to the cloud, where on the serverless architecture, the data is being processed and stored into the Azure Cosmos DB that can be used by the application later on. The same data is also stored in the Azure Blob Storage so that it can be used for advanced analytics use cases later on. The application uses the data and exposes only the set of information depending on the roles and responsibility of the user as per the battery passport specification over web and mobile application. The solution is designed using the eInfochips Azure-based accelerator named EIC Propel. So it helps you to reduce your 30 to 40% of your overall battery passport solution timeline to market and can really help you to launch faster. Now I will hand it over to Amra to explain you about the battery passport case study that eInfochips is implemented. Over to you, Amra.
Thank you again, Shaleen. Let's now look at a case study of the NXP Secure BMS solution and how it supports the battery passport. This solution is designed to meet the EU battery passport requirements, ensuring that all important data about the battery's life, health, and safety can be trusted and securely delivered to the cloud. The use cases supported here include secure communication between the BMS host and the cloud service, management of battery passport related data in line with EU regulations, and a secure AWS cloud connection to guarantee integrity from the vehicle to the backend. What makes this powerful is that NXP provides a one-stop solution, a production-grade BMS platform with the necessary hardware, firmware, and even safety artifact. On top of that, software-defined features and a dedicated battery passport applet to make compliance straightforward. From a security perspective, the system ensures that data like SOC and SOH is delivered securely through TerraSolve in vehicle gateway and verified in the cloud. This relies on NXP automotive secure elements, which are common criteria certified at EAL5 plus and above, giving the highest level of assurance. For communication flexibility, the platform supports CAN FD, Ethernet, and NFC. The NFC channel is particularly useful when the system is offline or after a reflash because it still allows retrieval of secure battery passport data. So, in short, this solution addresses both the regulatory needs and the technical challenges for implementing a secure, trustworthy battery passport. Finally, let's take a closer look at the secure BMS system diagram and focus on the role of security and data flow. The BMU boards gather measurements from the CMU and BGB boards, parameters such as voltages, currents, SOC, and SOH. Once calculated, this data is handed over to the secure element integrated on the board. Inside this secure element runs the NXP BMS applet, which gives the chip the ability to store, sign, and manage the data securely. Communication between the microcontroller and the secure element happens over I2C, with a secure library in the firmware. Importantly, all data is exchanged within a secure encrypted session created by the hardware security engine. The secure element then signs the battery data and stores it internally. When the system needs to share this information, then you have multiple paths. If the gateway is active, the controller establishes a TLS secured session with the gateway, retrieves the signed data from the secure element and sends it to the cloud. The cloud then verifies the digital signature to confirm authenticity. Alternatively, if the system is powered off and or not connected by Ethernet, the mobile application can connect directly via NFC to the secure element, retrieve the signed battery data, and still upload it securely to the cloud. This dual path approach ensures that the battery passport data is always accessible, always trusted, and always secure, no matter the situation. And with that, I want to thank everyone for your attention, and I'll hand the presentation back to Shaleen.
Thank you, Amra. For this case study on the digital side, we have implemented on the AWS IoT Core for real-time updates of battery parameters, authentication mechanism and communication to the cloud service on the AWS. From the database perspective, we are storing the parameters such as battery ID, user information, timestamp, and security channel through which the data is being communicated. And there is a web portal and Android iOS mobile application that is available for users to see the battery data. The Android and iOS mobile app, here you can see it has the ability to communicate to the battery through the NFC. And there is a secure element NCJ37B0HN that is being used to communicate through the battery and obtain the data. Similar way, the web portal is fetching the data from the cloud side.
These are the secure BMS
web portal that is implemented for battery passport solution, where you can see that there is a specific battery management system ID and the token that is being inserted to see the battery performance data. This token-based authentication has a significance so that you can only see the battery-specific information when you're looking at the health and performance of the battery passport data. These are the secure battery management system battery passport mobile application, where you can see the data on the Android and iOS mobile app. With mobile app, there is an additional feature that supports the data of battery passport from the NFC. So if the cloud connection data is not available, or if someone wants to see the data directly from the battery, then they can use the NFC option. You can see that on the web and mobile portal, there is a data that is being displayed on the cloud and in the NFC, and this NFC specific data is also available. The use case is that in the energy storage environment, if the user wants to see the battery specific data by tapping onto the battery through the QR code, then they can use the NFC feature to see the data directly coming from the battery passport. So that's the end of the presentation. I will hand it over to Colleen so that she can take the question and answer. Over to you, Colleen. Thank you.
Excellent. Well, thank you, gentlemen, for a fantastic presentation. To our audience, we're now moving on to the question and answer portion of the event. So if you haven't done so already, please go ahead and enter as many questions as we can. Enter your question into the Q&A text area, and we'll get to as many as we can in the time that we have left. So again, just enter your question in now. And I'm going to go ahead and get started because we do have quite a few that have come in. So I'll start here. Our first question asks, in your opinion, how should producers of materials, chemicals that are used in the production of batteries should prepare for such a battery passport? What is the expectation of their role in the value chain, and when should they start preparing themselves?
Okay. Colin, I'll take this question. The expectation of this role is to provide the complete transparency of the battery make and material being used. Specifically in the European region, this regulation, as mentioned in the presentation, come in force from February 27. So the producers should have the ability to provide this type of a data when they start selling batteries to OEM. So typically, the implementation should start closer to the 27 timeline, but should be able to prepare themselves at least a year in advance.
Excellent. Thank you for that. Again, to our audience, please go ahead and enter your question in now, and we will get to as many as we can. Our next question asks, what is the value proposition of eInfochips for battery passport solutions?
Yeah. So from an eInfochips perspective, the value that eInfochips bring in is its ability to have a partnership with the different semiconductor companies, such as NXP, TI, Infineon, onsemi, so that they understand the device, the battery, and the components associated with it. And similarly, we have the ability to integrate with these devices and fetch the data related to battery so that it can be securely stored onto the cloud. So eInfochips acts as an H2 cloud single vendor who can help you to do both the work on the hardware and the battery side as well as on the cloud side.
Excellent. Thank you, sir. Moving quickly along here so we can get as many as we can in today. Next question asks, does battery passport solution of eInfochips work with only NXP reference designs?
Well, eInfochips battery passport solution is generic in nature, so it can be implemented with any semiconductor company chipset. However, the chipset-specific feasibility and the capability for battery passport can be evaluated by eInfochips when we engage with customer. So the solution is very well suited for any kind of a chipset or the device that is available.
Excellent. Thank you, sir. Moving along here, our next question asks, how do you be sure the SOH is properly calculated? Every BMS manufacturer has its own way to calculate SOH.
If you can take this question, that would be helpful.
Yes, actually, the battery passport is not concerned with the accuracy of the SOH and the SOC. The battery passport takes this as an input and store it either into the secure element or upload it to the cloud. Okay, so from the battery passport perspective, there is no thing or requirement to define the accuracy of the SOC and the SOH. But regarding how these algorithms are accurate, it depends on the algorithm nature itself in the construction of it. Is it based on OCV and column counting, or based on Kalman filter or advanced AI algorithm? This is another topic regarding the SOC and SOH. But for battery passport, SOC and SOH is taken as an input from the BMS, stored it securely into the secure element, and uploaded securely to the cloud to track the battery into the different application in the second line. Thank you.
Thank you, Armor. Our next question asks again to our audience. We'll get to as many as we can here today, left in the few minutes we have. The next question asks, how can a system display battery information to the end user in line with the EU battery passport requirements?
Okay, let me take this question. So there are two use cases that we explain in the solution. One is where if the battery is connected to the cloud via the gateway, then the battery information can be displayed on the web portal or the mobile application, considering that it is connected to the internet through the gateway. Let's say in certain cases where the batteries are offline in nature, then there is a NFC channel, a connectivity through the secure element available on the battery, so that a QR code can be scanned on the battery to see the data directly over the NFC channel into the mobile application. So the information is available both online and offline in nature, depending on how you want to access the information of battery.
Excellent. Thank you, Sheldon. Next question asks, I'm going to get through, I think, a few more here. We've got a few minutes. What is the battery weight required for EV and LMT type of transport to comply to battery passport?
So as per the battery passport regulation version 1.2, which is released in January 25, for EV, the battery should be more than 25 kg in weight. That has to comply to the battery passport requirement. And for LMT, it should be less than or equal to 25 kg. However, in general, the guideline is that any battery which is more than a 2 kilowatt in nature has to comply to the battery passport regulation, irrespective of the use case being implemented.
Excellent. Thank you, sir. Quickly moving on here, what is the official regulatory body for battery passport requirements?
So, Global Battery Alliance, GBA, is the governing body of the battery passport specification that governs the specification, and there are industry experts, companies, and technology companies who are involved in developing this battery passport specification.
Excellent. Thank you. Looks like I'm going to be able to get to hopefully two more. Next question asks, data attributes shown in the webinar, are they part of any specification?
Yes, so the data attributes that are being shown are part of the battery passport data attribute long list released in January 25, version 1.2, and the relevant resources for search attributes can be found on the batterypass.eu/resources website.
Excellent. Thank you. Okay, quickly moving along. We're getting through quite a few of these. I'm really excited here. So let's get to our next question. Next question asks, how detailed does the data collected from the battery pack, specifically the cell voltage collection, need to be stored in the battery passport itself? Does the passport track individual cell voltages over the full life of the pack, or does it just store the most recent data for cell voltage data?
Okay, the cell voltage data itself is not stored into the battery passport. We are concerned, there are two types of parameters, static parameters and dynamic parameters. And the dynamic parameter like the SOC and the SOH, but battery voltage is not tracked through the battery passport. But we track the parameters that really indicate about the health and the energy storage and how this battery can be used into different applications or in the second life after leaving the energy storage into other simpler applications to identify if this battery can be used or not without any tampering in data from anyone that may cause a disaster due to the overusage of this battery. So in short, the battery voltage is not stored or is not a part of the parameters of the battery passport.
Excellent. Well, thank you for that, Amar. Looks like I have one more question here, and this one asks, are both AWS and Microsoft Azure Cloud supported for battery passport solution?
Yes. So eInfochips supports both AWS and Azure as a cloud for battery passport. With eInfochips, we have EIC Propel as an accelerator, which can be used that can greatly improve your time to market for battery passport solution. And the reference case study that we discussed in today's webinar with NXP was implemented on the overall AWS cloud. So both clouds are supported and it can be implemented.
Excellent. Well, thank you. Thank you very much, Shaylin and Amar, for excellent Q&A. Thank you to all our speakers today, and thank you for attending today's webinar. So for more information related to today's webinar, you can visit any of the resource links in your resource box located to the right of the presentation window. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. So please be sure to go ahead and download that deck as well. And thank you for attending today's webinar, Comprehensive Battery Passport Solution for Next Gen Energy Storage Systems. This webinar is copyright 2025 by AspenCore. The presentation materials are owned by or copyright by Tech Online, eInfochips, and Arrow Electronics. The individual speakers are solely responsible for their content and opinion. On behalf of our guests, eInfochips and Arrow Electronics, I'm Colleen Heckman. Thank you for your time, and we hope you have a great day.